Welcome back. We just talked about ECMP. We talked about high availability of the service routers. And here we're going to look at the service routers in a different light. We're going to look at them in the context of the SR and DR, the larger gateway as a whole. And what we're going to do is we're going to explore how the packets flow through all these pieces. That's really what this video is about. Now we're going to break this up. Actually, it's not going to be one video. We're going to break it up into a couple. This video is going to talk about single tier topologies. So that's going to be just a tier 0 gateway and no other routers and virtual machine hanging off of that. The next video is going to get into multi-tier routing, where we're going to add a tier 1 gateway into the mix. So that's where we're going. That's what's going on. So we look at this and we want to kind of set the stage. We want to talk about the scenario for a second before we dive all the way into the packet walk. Now, I have a virtual machine. Right? The virtual machine has an IP address of 10.1.1.10, and the virtual machine is attached to an overlay segment. So the virtual machine is inside of NSX. And that segment is attached upstream to a tier 0 gateway, right? So our tier 0 gateway has a downlink directly to this overlay segment. And the uplink on the tier 0 gateway connects out to a physical router. And that physical router can get us out to our destination, which is 192.168.10.1. So we've just got that one tier of routing inside of NSX. And so we look at that and we think about that. When my virtual machine wants to talk to that physical machine, right? It's gonna craft the packet. It's gonna look at its routing table, and it's going to find that the closest match to 192.168.10.1 is going to be its default route at 0.0.0.0/0. And that default route points to the default gateway of the system, right? That default gateway is hosted by my tier 0 gateway, more precisely by the distributed router on my tier 0 gateway. That default gateway has its 10.1.1.1 address, and so that's where we're going to forward the packet from the virtual machine. So we're going to send the packet to our default gateway. The distributed router, right, the tier 0 distributed router on the hypervisor is going to do what any other router is going to do. And it's going to look at its forwarding table and say, okay, where's my match for 192.168.10.1? And we're actually going to find, in this particular case, if you look closely at the output here, we're actually going to find a route specifically for 192.168.10.0/24. We've got a route programmed for that, and it says we need to forward that to 169.254.0.2. Now, where did that IP address come from? Well, that's the default subnet that the intra-tier interfaces are going to have, right? If you remember back to our interfaces discussion, so many videos ago, we have the DRSR interface, right? The intra-tier interfaces on our gateways. Well, those are attached to a logical switch, but their address, the subnet, is going to be a 169.254 link local address. So since my DR on the hypervisor is attached to that segment on the hypervisor, we're going to go ahead and forward that packet from the DR out onto the logical switch. Now, what happens here? Well, what happens here is we have to go through a logical switching packet walk, because we're moving a frame across a logical switch from one transport node to another, right? When that packet, or when that frame destined for, I guess it's a packet technically if we're going to talk IP addresses, when that packet destined for 169.254.0.2 gets to the logical switch, gets to the virtual switch, we're going to do a lookup on the destination MAC address. The destination MAC address is going to show up as serviced by the tunnel endpoint on the edge transport node, because that's where the service router lives. That's where that interface is connected. So we're going to encapsulate that layer 2 frame in a Geneve packet, and we're going to send that Geneve packet across the transport network, right, the physical transport VLAN, out to the edge transport node, to the tunnel endpoint on the edge. Once the Geneve packet gets to the edge, we're going to strip all the headers off, right? We're going to decapsulate that Geneve packet, and that layer 2 frame will then be sent to the service router. The Tier 0 service router is going to pick up that payload. It's going to strip off the layer 2 headers and look at layer 3, because that's what a router is doing. And it's going to see that we're destined for 192.168.10.1. So it's going to validate or check that against its routing table. And we can see that there is a route for 192.168.10.0/24. We can get to that subnet. We can get to that subnet by going to the external gateway, right? We can forward this across our uplink to the external router, and that'll get the traffic where it needs to go. We can tell that this is a static route by the flag. Notice the flag says T0S, Tier 0 static route. So somebody's programmed this route in as a static route. This is not a BGP route or an OSPF route. This is just something we've manually configured. Well, we need to forward this packet across the uplink out to the physical network, and that's exactly what we're going to do, right? Once the physical router receives that packet, once we send the packet, it's out of our visibility. So the physical router will do whatever it needs to do to get to the destination 192.168.10.1. Now, we can't stop here. We can't stop here because network conversations are not typically one-sided, right? So 192.168.10.1 is probably going to send a packet back to 10.1.1.10 to our virtual machine. So what's going to happen there? Well, the same thing. It's going to look at its routing table. It's going to see that the best match is going to be its default gateway. It's going to forward to its default gateway, which will forward the packet eventually to our peer, right? That peer router to NSX is going to know to send a packet into NSX to get to 10.1.1.10. So the service router is going to pick up and receive that packet, right? The Tier 0 service router will receive the packet from the virtual machine. And what are we going to do? Well, the service router is a router component. It's going to look at its routing table, and it's going to see that it's got a connected route to 10.1.1.10. All right, we can tell that by the flag on that route. It says T0C, Tier 0 connected route. The service router is going to forward out the interface to the virtual machine's segment. All right, we have direct access to that on the edge node. Remember, the edge is an active transport node. All of my logical switches extend to my edge. So we have direct access. Remember, the service router and the distributed router are part of the same gateway, so they share ownership of the interfaces on the edge where they both exist. So the service router can forward a packet directly out the interface on the segment. So we do that. Well, what happens there? Well, since we're forwarding ultimately a layer 2 frame to a logical switch at this point, right? Because the Tier 0 gateway is going to put Ethernet headers on this. We've got a layer 2 frame. We've got a destination MAC address of my virtual machine. And my virtual switch is going to look that up and say, oh, well, that MAC address is serviced by this other TEP, by this other transport node. So again, we have another logical switching packet walk to follow where my tunnel endpoint is going to encapsulate that frame. It's going to forward that frame across the transport VLAN to the destination ESXi host. And the tunnel endpoint on that ESXi host will strip away the Geneve headers and will look at the frame and put that on the virtual switch. The virtual switch will then forward that payload out to the virtual machine itself. So we look at logical switching packet walks, or logical routing packet walks rather, and we see that there's both logical switching and logical routing involved because we need the logical switching to move the resulting layer 2 frame from transport node to transport node, from hypervisor to edge, from edge to hypervisor, right? So logical routing does not happen in a vacuum. It happens in concert with logical switching. So that's our single tier topology. That's single tier routing. Now, take a quick break. We'll come back in the next video. We'll talk about multi-tier routing, and we'll kind of see what things from this video we're going to bring over and what new things we've got to think about there. We'll see you in the next video.